Hi everyone, this is the Dr. S. Venkateswarlu, working as a professor of EC at IARE. Today we will be discussing about response of a DT systems involved with convolution. So here define input pulse response. It is followed by H of n as a response of the DT LTI systems to a unit pulse function delta of n. For this, using the principle of the time invariance. So, using the principle of linearity, we will verify so that what the h of n and delta of n using this principle of the time invariant principle of linearity, how it is varies mathematically and so on. We have to recall that what you call linearity implies that weighted sum of input signals. So will produce a similar weighted sum of the output signals. After that, each unit pulse function delta of n minus k. So how it is produced the corresponding signal, or maybe h of n is involved, or delta of n is involved. For this, the time delay version of the system impulse response function, it is followed by h of n minus k. Okay, this h of n minus k, so it is responses with this h of n and delta of n, how it is where is the delta of n minus k. So for this, okay, the summation is referred to as the convolution sum. So with this, so with the unit pulse response h of n as the response of the DT linear time invariant system to in unit pulse function, it is followed by particular delta of n. Using that, it is involved the time invariance. Here it is delta of n tends to the h of n. So delta of n minus k is to h of n minus k. Using this particular principle of the linearity, so we need to verify that how it is varies that x of n, where x of n is the summation k, ak x of xk of n. Within this, so we can write this where x of n is equal to what you call the summation k ak xk of n. With this, so the input is given to this system. Okay, so we will expect that our output response is y of n. Y of n is the summation k, bk, yk of n. Okay, that the system is h of n. It will be the unit impulse response will be involve this x of n. It is given that h of n. We will try to verify that response y of n is equal to summation k, bk, yk of n. Okay, so by using this all linearity with reference to this, the summation, that x of n, where x of n is equal to the summation k equal to minus infinity to plus infinity, x of k into delta of n minus k. So now it is involved that x of n, x of n response. Okay, so where y of n, we try to interpret this y of n is equal to the summation k equal to minus infinity to plus infinity x of k into h of n minus k is equal to x of n convolved with the what you call h of n. So using this on mathematical analysis, recollect that linearity implies that weighted sum of the input signal will produce the similar weighted sum of output signals. So each what do you call unit impulse function, the delta of n minus k, produces the corresponding time delayed version of the system impulse response function. It is h of n minus k. Okay, so the summation is referred to as the convolution sum. The symbol is the what do you call convolution. User can represent this what do you call convolution sum is used to denote the convolution operation. Okay, so where if you are using the convolution operator with reference to this convolution operator, okay, or you can consider the convolution sum. Once it is the y of n is equal to the summation k equal to minus infinity plus infinity x of k into h of n minus k is equal to where x of n convolution operator with h of n. So that we easily can verify the convolution sum. Within this, so the linear time invariant system and impulse responses. So it is by using this system, linear time invariant systems of the outcome of this impulse response, how it is varies. The output of any DT LTI system, linear time invariant system, is a convolution of the input signal with the unit pulse response. The response in terms of this, what do you call that, of x of n, where x of n or maybe x of n with this dts and dts. Okay, discrete time and discrete continuous time signal, where LTI is the convolution of the input signal with the with the unit impulse response. So any DT LTI system is completely characterized by its unit pulse response. The response is involved. Convolution has the simple graphical interpretation. Using with reference to this mathematical analysis, you can verify that. We will verify that graphical interpretation. Within this, so we have to consider that. So what we call where x of n, where that x of n is given to that impulse response h of n. We will expect that all output response where y of n that y of n is equal to particular x of n convolve with the h of n. Within this, the LT system is completely characterized by its unit pulse response. Okay, convolution has the simple graphical interpretation. Okay, that graphical interpretation is depending upon that what you call that x of n. So the output of any LTA is a convolution of the input signal with the unit pulse response, where x of n is equal to summation k equal to minus infinity to x of k into delta of n minus k. The time we like to verify that output, where y of n is equal to summation k equal to minus infinity to plus infinity x of n into h of n minus k. It is also equal to x of n convolved with the h of n. Okay, any DT LTI system is completely characterized by its unit pulse response. Convolution has a simple graphical interpretation. That graphically you try to interpret this one, where unit sample is, it is followed by where delta of n versus x of n. That unit sample is ready to verify that where n, go on using this n value with delta of n. So that unit sample will be appear like this, x of n, n versus x of n. That means that is where that unit sample is fed to the DT LTA system. We will expect that all output response is y of n in graphical, because of the convolution and the simple graphical interpretation. That interpretation is depending upon unit sample. It is given to the DT LTA system. So we will expect this graphically, where n versus, when compared to this one, that x of n. Okay, so like this, try to verify that y of n. Okay, next shift invariance. There's a shift variance. So now it is shifted to that here n versus that x of n. Now it is shifted to here. So it is given to this what you call DT LTA system. We will expect that all output response like this. So where here, where n versus y of n will be represented like this. Okay, next scaling. So the convolution as the simple graphical interpretation is depending upon scaling. The scaling factor n versus what you call delta x of n. It is given to that the DT LTA system. We will expect that output response here. graphically. So n versus y of n. Like with reference to the superposition, where n versus x of n, like this, the signals are the simple graph representation here. It is given to this, the DT system. We will expect that vertical n versus y of n, like this graphical representation. Try to verify here that easily can interpret the convolution as the simple what do you call graphical representation. It is mentioned where n versus y of n. Okay, this is related convolution has a simple graphical interpretation. With reference to this, usually can analyze that how it is affect with the different input value with the DT LTI system within this unit sample, or the output and shifting variance and scaling and superposition. Next, visualizing convolution. How we are verifying that is visualizing the convolution? The convolution is there are 4 basic steps to the calculation. So for visualization purpose, the convolution is where x of n is equal to the summation k equal to minus infinity to plus infinity using this all mathematical analysis. So there are 4 basic steps to the calculations. So the operation has the simple graphical interpretation after calculation of that. Try to verify here. Where h of k is equal to flip h of minus k. Yeah, if it is shifted, h of n minus k, and multiply x of x of k into h of n minus k. It's a summation where summation k equal to minus infinity plus infinity x of k into h of n minus k, like this. So the 4 basic steps will be calculated using this h of k. So after that, ready to visualize this convolution, how it is varies. So here the operation has a simple graphical analysis where n is like this, where n equal to 0, 1, 2, 3, 4, and so on 5. You can see like this. Okay, n versus x of n. So where h of n versus h of n, it will appear that's minus 1, 0. By here it is minus 2 or minus 3, 0, and so on 1, 2, 3, and so on n versus h of n. So from this x of n and h of n to x of k and h of n minus k. So it is right to verify that where from x of n and h of n to x of k and where x of k and h of n minus k. X of k is ready to verify here, where k versus this value, like this. So the operation has a simple graphical representation with x of k into h of n minus k. So here note that h of n minus k is the mirror image. How we are verifying that mirror image? So by using this the basic steps of the calculation h of k, flip and shift and multiply and sum, the operation has a simple graphical representations. It is depending upon n versus x of n and n versus h of n, from x of n and h of n to x of k and h of n minus k. So here where h of n minus k is the mirror image of h of n minus n, with the origin shift to n, like this, where it is h of n minus k. Try to mirror the mirror image of h of n minus n. Okay, like this here with the k versus h of n minus k. Okay, and where if it is n is it is observed this n plus 1 and n minus 1. Okay, this is the related to the visualization convolution. So next, calculating the successive values. How we are calculating the successive values? Look at this. We can calculate each output point by shifting unit pulse response one sample at a time. Okay, the sample is where y of n is equal to summation k equal to minus infinity to plus infinity x of k into h of n minus k. So go on substituting this all value where n and k value. So easily can try to calculate each output point by shift the unit pulse response one sample at a time. Okay, like this where n is so 0, 1, 2, 3. Like this where n is value 0, 1, 2, 3 and so on where the x of n. So like this here h of n, try to observe this. Okay, so now for y is equal to 0 for n, how it is varies after that. So where y of minus 1, so easily can ready to calculate. After that y of 0 and so on. The y of 1 and y of 2, y of 3 and so on. Easily can verify that due to that y of n is equal to the summation k equal to minus infinity to plus infinity x of k into h of n minus k. So and so on. So where y of n is equal to 0 for n, so less than maybe minimum value or maximum value. So can we generalize these results with reference to this value where k versus x of k. Where k is versus x of k. So here it is minus 1, 0, 1, 2 and so on. So after that where k is varying with reference to h of n minus k. So where n plus 1 and n minus 1 where this value is we are right to generalize this particular result if it is y is equal to 0 for n greater than this particular value. Like this, the graphical convolution. So easily can verify that graphical convolution where h of k within this we here that here it is 1 and 2 minus 1 and so on. Like this, easily can ready to verify where x of k is here where y of minus 3 summation k equal to minus infinity to plus infinity x of k h of minus 3 minus k equal to 0. Okay, where h of minus 3 minus k we right to substitute this value. So easily can graphical convolution will be varies where y of minus 2 the summation where y of minus 2 is equal to the summation k equal to minus infinity to plus infinity x of k h of minus 2 minus k equal to 0. Okay, next where y of here h of minus 1 here h of minus 1 minus k within this how it is varies that y of minus 1 is equal to 1 into 1 it is followed by 1 like this. So where h of 0 similar case where h of 0 to k how it is varies. So where y is where y ready to substitute where y of n is equal to where y of n is equal to where n is ready to substitute either 0 or 1 and 2 and 3 and so on like this. So where h of 0 minus k, so y of 0 equal to 1 y of 0 equal to so 1 into 0 plus 2 into 1 plus simply we write to verify that 2. This is the graphical convolution by substituting these values with reference to h of k and x of k and h of minus 3 minus k and h of minus 2 minus k. After that h of minus 1 minus k, h of 0 minus k. So ready to verify that k value is ready to assign these all values where k equal to minus 6 minus 5 2 minus 5 minus 4 minus 3 minus 2 minus 1 0 where k equal to 0 k equal to 0 k equal to 1 2 3 4 5 6 7 8 and 9 like this graphical convolution will be observed within these convolution effects. So these effects where h of k with this same the k values are here it is given that h of k where k equal to, here it is k equal to 2 here based on this all 2 value. Okay, so where x of k, where h of minus 1 minus k, where y of n, where n is y of n is equal to minus 1 into 1 plus 2 into 2 into 0 plus minus 1 into minus 1. Here it is, right, to verify that minus 2. Similar case, if it is y of 2, where y of 2 is equal to, so what do you call, 1 into 0 plus 2 into what do you call minus 1, so plus what do you call minus 1 into 0, okay, plus minus 1 into 1. After simplifying this, let verify that minus 2. Okay, and similarly y of 3, where y of 3 that y of 3 is equal to 1 into 0 plus 2 into 0 plus what do you call minus 1, okay, minus 1 into minus 1 into 0. So right, verify that after using this all simplification, so that is equal to 1. Similar case where y of 4 is equal to minus 1 into minus 1, here it is 1. Like this, we will verify that how it is affects the graphical convolution. If we are varying that what do you call, where h of k, x of k, h of 1 minus k, h of 2 minus k, h of 3 minus k, and h of 4 minus k, and so on. Okay. Yeah. So under this graphical convolution, there is a using this all graphical representation. What is your observation? Or here it is graphically it is mentioned with somewhat it is substituted. How is graphical convolution is effects? What is the major observation? The observations are here the y of n is equal to 0 for n greater than 4. This is the major observation. And if we define the duration of h of n as the difference in the time from the first non-zero sample to the last non-zero sample. Okay, like the duration of h of n, LH2 is 4 samples. Because of that, y of n is equal to, where y of n is equal to 0 for what you call n greater than 4. Okay. Now similarly similarly lx equal to 3 is where the duration of the y of n is ly is equal to lx plus lh minus 1. Okay, this is the good sentence check. Okay, so within this, the fact that the output has a duration longer than the what you call input indicates that convolution often acts like a low pass filter and some what you call smooths the signal. Smooth, like it allows only low frequency components. It opposes high frequency components, like the fact that the output has duration longer than the input indicates that convolution often acts like a low pass filter and smoothness the what you call signal. That is our expected things by using the graphical convolution. Major observation is it is depending upon y of n is equal to 0 for n greater than 4. If h of n is the difference in time from the first non-zero sample to the last non-zero sample. Okay, so within this, which one is the, based on this all duration, the duration of y of n is ly is equal to lx plus lh minus 1. That how it is varies. About the effect using this all observation. The fact that the output has a duration longer than the input indicates a convolution often acts like a LPF, low pass filter. So finally, it is smoothness the signal. Okay. Next. So example of DT convolution. Yeah, we will try to verify that unit step and delayed unit pulse and integration within this discrete time convolution. So unit pulse, how it is affect, and delayed unit pulse. After that, we will verify that unit step and integration. Okay, that unit step is represented in mathematically. H of n is equal to delta of n, where y of n output response y of n is equal to the summation k equal to minus infinity plus infinity x of k into h of n minus k. The finally y of n is equal to summation k equal to minus infinity to plus infinity, okay, x of k into delta of n minus k is equal to x of n. This is related to unit pulse. Coming to this unit step, that unit step h of n is equal to u of n. Here this case where h of n is equal to delta of n, where in h of n is u of n, how they are calculating y of n, where y of n is assigned where summation k equal to minus infinity plus infinity x of k into h of n minus k. It's also equal to that y of n is the summation k equal to minus infinity plus infinity x of k into u of n minus k is equal to the summation k equal to minus infinity to n into x of k. Okay. After x of k, how it is, where is that unit step? Next, coming to this delayed unit pulse. The delayed unit pulse, it is followed by h of n is equal to delta of h of n is equal to delta of n minus n naught. At the time where y of n is equal to the summation k equal to minus infinity to plus infinity x of k into h of n minus k. Within this, that output is where y of n is equal to the summation k equal to minus infinity plus infinity x of k into delta of n minus n naught minus k. It is also equal to the x of n minus n naught. So similarly, that integration also you have to verify that how it is varied the h of n or the DT convolution varies. Okay, like this where x of n is equal to u of n, where h of n is equal to a power u of n with a power less than 1. The time where y of n is equal to the summation k equal to minus infinity plus infinity x of k into h of n minus k. Where y of n is equal to the summation, summation where it is k equal to minus infinity to plus infinity within this u of n and a power u of n. Where the time where 1 it is delta of n plus 1 minus a into delta of n minus 1 and so on, and leave that verify that where n is equal to 0 and is equal to n greater than 0. Within this, so what are the properties of convolution? So basically we know that our properties, normally there is a popular lot of properties are available, but what are the familiar what do you call popular properties, which is how it is affected in further application and so on. We have to investigate the properties of the convolution. So one is the commutative, which where x of n convolved with h of n is equal to h of n convolved to x of n. So like it is considered what you call commutative property. Next one, distributive property. The distributive property is where x of n convolved with h1 of n plus h2 of n is also equal to that what you call x of n converted into h1 and h1n plus x of n converted with this x2 of n. Okay. Next, associate. That associative property where x of n, so it is given to that x of n is given to h1 of n. So output response x, x1 of n is x2 of n. So finally we will export it y of n. Next, so after that, after how it is associated where x of n, h1 of n converted with s2 of n, then we will write to reflect y of n. Okay, next where x of n is fed to the s2 of n, given that h1 of n both are associated with, we will expect that output response is y of n. Like this is the popular properties while you are using that convolution. Okay, so within this, next implication where x of n is given to the h of n, we will expect that y of n. There's a response and x of n the input, that the system is h of n, and output to verify that y of n is also equal to h of n. It is given to the x of n, we will expect that y of n. It is all our implications. Okay. Next, where x of n, within this x of n, h1 of n plus h2 of n, we will expect that y of n. After that, it is given to that where h1 of n it is predicted, h2 of n by using this algorithm we have to verify that particular property is involved with the implication. Next, next property, there is a useful properties of DT or LTI systems. One is causality. Causality or causality. It is followed by the summation k equal to minus infinity to plus infinity h of k is than infinity. So where h of n is equal to 0, n less than 0. Okay, next with the stability, the causality is h of n is equal to 0, n less than 0, and stability is the summation k equal to minus infinity to plus infinity mod h of what you call h of k less than infinity. Next, bounded input and bounded output. So sufficient conditions. So based on this sufficient conditions for x of n, where it is x of n is less than or equal to x maximum less than infinity. Yeah, for x of n less than x maximum less than infinity, the time we have to verify that y of n, where y of n is equal to, so that summation where k equal to minus infinity to plus infinity, where x of what do you call k, h of n minus k. Okay, after that we have to verify that if it is less than or equal to x maximum, the summation k equal to minus infinity to plus infinity h of n minus k less than infinity. Okay, like this. Next, necessary condition. So this necessary condition is depending upon what you call this, if the summation, if the summation k equal to minus infinity to plus infinity, h of n minus k mod h of n is equal to infinity. Next, if let x of n is equal to h convert with minus n by h of n minus 1, then mod x of n is equal to 1. It is bounded. Okay, next, y of 0 equal to the summation, so k equal to minus infinity to plus infinity. Oh, okay, so where it is x of k into h of 0 minus k, the summation, what do you call, h convert with minus k into h of minus k by h of minus k equal to what do you call that summation, k equal to minus infinity plus infinity h of minus k mod is equal to infinity. Next, so like this, we try to verify that all useful properties of discrete time systems with reference to this linear time invariant system with discrete time variation. We using the different properties, how it is varies by using these normal properties. Like the properties are, we have to use the popular properties of convolution. One is the commutative and distributive, associative and implication, and so on. Okay, with this, these useful properties of discrete time and linear time invariant system. System base, one is causality, so the stability, bounded input and bounded output, and the sufficient conditions will be applicable for this. So, using these all necessary conditions, so I have to verify this medical useful medical properties based on this LTI system. Okay.
Like, share and subscribe. Hit the bell icon for more updates.